Hi everyone, and welcome to this chapter of Dart Crash Course. In this chapter, we're going to talk about collections. Now, as we've talked about it before in the beginning of this course and almost in every chapter, if you're watching these videos, then you're probably already familiar with another programming language from before, so you are probably already familiar also with collections. And these are like things such as lists, maps, or as they're called in other languages, dictionaries, and iterables, and etc. So we're not going to go too deep really with the meaning of collections. I'm just going to assume that you already know what collections are, but we're just going to go deep into the topic of collections in Dart and like different methods to work with lists and iterables and maps. So let's do what we usually do and create a project for our application. So I'm going to bring up a terminal window in here, and we say Dart create with a template of console, and we say collections, just like that. Then we can go inside our project. So we say code collections. Okay, and we'll get rid of this terminal window and of course the usual dance of workspace JSON with the zoom level I think of 6, and then we can get fswatch in here as well. Let's see if you can get rid of the explorer, and we say fswatch, and of course example 1, which we haven't created yet, but we're going to do that now. So let's then go into the bin folder, get rid of this default file in here, and create a new file, and we call it example1 Dart with a main function, and we can say print something in here. Okay, so we can see now it is being printed to the console, so we can get rid of the explorer and also the terminal. So the first thing that we're going to discuss in this chapter are lists. And lists are some things that we also call arrays in other programming languages, such as TypeScript, for instance. So lists are simply a collection of values that are written in serial. So they start at index 0 and they go ahead until index n, for instance. So as many items as you have. So they're zero-based collections, at least they're indexes. So let's create like an array of names, and we say, let's say in here, maybe we could just say foo and bar. Let's say foo and see if GitHub Copilot can complete this for us. There we go. Okay, so here's a collection. If we move our mouse over it, you can see it's a list of strings. So it's a collection of strings. It's an array, you could also say. So it's an array, list, or a collection. Dart calls them lists. So you can see in here, the actual class name is list, and you can press Command T in Mac OS or Control T in Linux and Windows and Visual Studio Code and just type list, and you can actually get to the source code of how lists are created. So let's see if we can get the source code for list. Here we go, maybe somewhere in here. And let's see if we can find an async math type collection. Perhaps if you go into Dart collection, and then we can see list in here. Boom. And then here is the base class for list. So you can have a look at the how basically the Dart team has created the class for lists and see why it is a generic class as well, as you can see in here. We're going to talk about generics later, so don't worry, we're going to have a separate chapter talking about generics, but it's just a generic class that allows you to create basically a list of anything in here. It can be a list of integers, doubles, it could be a list of a custom class, or it could be even a list of objects, meaning it's like a mix and match bag where you have integers and strings and doubles in here. So it doesn't necessarily have to be a homogeneous list, for instance. Okay, so here we've created a list of names, but how do we go through these? We've already talked about control flow, and we've looked at how we can create for loops. So we can say for final name in names, and then we can print this name. Okay, so if you look at the results, then you can see the names being printed to the console. So this is how you would iterate over them. Okay, so let's create a little separator in here because we're going to have quite a lot of examples in this particular example1 Dart file. So simply because collections have a lot of methods and tricks which we can use, it's a good idea to have all of those concentrated in one example Dart file. Okay, because if you go ahead and then say, okay, this is one example, and then we go and create another example Dart file just because we want to explain a simple method inside a list, then we're going to end up having perhaps 100 examples in this chapter. So in this particular chapter, we're going to concentrate a lot of our examples into one Dart file. Okay, and then move on to the next concept. Okay, so you can also reverse a list. We've already seen this before. So if we say for final name in names.reversed, so any list that you have, you can actually reverse it as well. Okay, so let's put our separator in here and see the results. So you can see here we've gone from the end of the list to the beginning, right? And Cox, Bass, Bar, and Foo. All right, so any list that you have, you can reverse it using this reversed property. And I'm not actually sure why it is a property. I mean, ideally this should have been a function because it's doing something and returning something. It's not exactly a property of a list. Like its reverse list shouldn't be a property of that list itself. At least really not in my opinion. But that's how the Dart team has done it. And if you have a list, you can always search for items in that list. So you can say, for instance, if names contains the value of bar, you can see it contains a function, and it says, okay, which element should I look for? And I will return a boolean. If I find that item, I will give you a true, otherwise I'll give you false. So in here, we can say bar is in the list, okay? And you can see the results printed to the console. And if you search for bar with a lowercase b, then it's not going to be found because equality on strings is case sensitive. So you need to ensure that when you're looking for an item, its equality operator is defined in such a way that it can actually be found. And we'll talk more about these when we have a look at, for instance, custom classes. But just so you know, if you go to the string class, let's go in and see if we can find it. Built-in collections. Let's see if we can find where the string class actually is. A string here. And if we search for equality in here, I wonder if we can actually find that. Here it is. So you can read the documentation for equality, how it is implemented by the Dart team on strings, but you just need to understand that it is actually case sensitive. So if you compare two strings, like if you say bar and bar are not equal, or these two are not equal either, only these two are equal. So the contains function basically goes through the entire list and then looks for that specific item that you specified in here using its equality. So it says, okay, are any of these items in this list equal to this value? And therefore has to call the equality function on string. Therefore, if you type bar with lowercase b in here, it won't be found. Okay. So hopefully that explains it. Now you can also test for objects existing, okay? And this is something that is an interesting concept because there is a function on lists and it is called where, and you can have a look at it here. It's called where, okay? So it expects you to pass a function to it that returns a boolean. So your function has to return a boolean for accepting strings. So it will give you every single string inside this array, inside this list. If you say true in your function for that string, then it will be included in the resulting iterable. So it is a little bit of a strange thing. It's kind of like saying, I will give you a bag of candies and I will pass you every candy in this bag, and if you say yes, then we will put it inside another bag. If you say no, I will put it back in my bag. So I'll give you the first candy. You say, oh, it's delicious. Okay, I want it. Yes. Then I say, okay, I'll put that in your bag. Then we continue this process until we've gone through all the candies in my bag, and then at the end of this process, I will give you your bag with all the candies that you asked for. Okay, and this is pretty much what the where function does. So let's say in here, we want to go through the names bag or the names list and extract every string from it where that string starts with the letter B. Okay, and that will be bar and bass, right? So foo doesn't pass that test, Cox doesn't pass the test, and it's only bar and bass that pass that test. So let's go and say names where, and here's the function we have to pass to it. So we say name, and we say as long as name starts with the letter B. Okay, so this is our function. Right? And you could actually extract this function into its own function. So this is just a closure. It's like an inline function. You can go ahead and here and say func. Sorry, I'm just so used to other languages as well. And in here we say we return a boolean, and we say name starts or string starts with letter B. And then in here we take the string we say value, and the result of our function will be return value starts with B. Then you can pass that function literally in here. You can say string starts with letter B. Okay, you can see it is happy about that. But instead we took this code here and we took, sorry, actually let's do an experiment in here. So let's change this function to an arrow function. So because it's just one liner, we say this is an arrow function. All right, and then we get rid of the return statement. And then what you could do in order to substitute, so in order to not have a separate function and instead have that as a closure in here, just literally take this with the parameter and its code, excluding the semicolon, and place it here. There we go. Do you see? That's pretty much how closures work. It's literally a function in here, okay? And then we can get rid of this function. So here we said names were the value or the name. Let's just change this to name. Starts with the letter B. And then in here, then we can create a loop through this. So we say for final name in that, okay? And then we can print the name. And let's put this print statement in here as well. So if we look at the results, you can see bar and baz being printed. Now, the result of this function is an iterable, and we haven't really talked about iterables yet, but we're gonna talk about them soon, so don't worry about that. That was about the were function and how you can pass a closure to it. Okay, now you can also use something called subscripts on lists, and that simply means that you go and peek at the list at the specific index. So you go and say at index 0, 1, 2, or 3. Okay, so remember lists are collections and they're zero based. So that means the first item has the index of 0, second item has the index of 1, 2, 3, etc., etc. So if you want to grab the value of foo, you could just say names element at 0, or you could literally remove this element at and put it in a subscript. This is what a subscript is, okay? So you can print this guy in here and you can say, give me the element at index of 0, at index of 1, at index of 2, and an index of 3. Okay, and then we can print our little separator in here. And you can see the result is exactly as if you just went through the list. So first item, second item, third, and fourth. Okay. However, be careful because subscripting a list at an invalid index will throw an exception. So you can't go and say, give me the element at index 4, meaning the 5th element. That will just crash your application simply because subscripts are not returning optional values. So here you can see an index of 4 won't exist because it's index 0, 1, 2, 3, and if you say 4th, your application will just crash. We can have a look at an example like that so we don't have to shy away from it. So there we go, and you'll see you get an exception, range error. Okay, so we can remove this. Now we've messed up our FSY, so we have to rerun it. There we go, and we can remove the invalid index from here. Now, you can put that kind of invalid index inside a try and catch. So you can say try print names at index of 4, okay? And then you can put a catch statement in here, and you will see now the exception is printed to the console. So you're not getting any exceptions in your application that crashes it. Okay, so you can always rely on try and catch if you're kind of not aware whether you're accessing an element that's out of range. But usually this type, I don't actually encourage this type of code because you should check the length of your lists before you go and access an element at a specific index. Okay, this type of code is okay if it is specifically written in the documentation for the function that you're using. For instance, let's say that you retrieve this name list by calling a function in a third-party library, and the third-party library tells you that, hey, here is a value at this index which you need to extract, and you try to extract that, but you get an exception. In that case, it's okay to get that exception because then you can contact the person who wrote that code and say, hey, the contract is broken. You said that I could access this index, but there is no value at that index. So in those cases, it's okay to kind of like wrap your code like this perhaps, and also try to fix the contract. But in most cases, you shouldn't write code like this. Just so you know, you should check the length of the list before trying to access elements at particular indexes. Okay, you can also extract sub ranges from lists. So let's say that we want to grab, if we say names, there is a function on any list. It is called sublist. You can see it has a start and an optional end. So let's just say we go from the start at index of 1. Okay, and then we could say for each. Now this is another function. So the result of this guy, let's put it inside a variable. You can see it's an iterable. It's actually a list of string. Okay, so it's a list of string, and every list has a function on it called for each. And this for each is kind of like a modern loop. So it gives you an element and it says, what do you want to do with this element in this closure? Now, if you just put the print statement in here, this element will be passed to that print statement. Okay, so it's kind of like you're passing a function to a function. So what happens in here, if we look at the results, you can see bar, baz, and cox are being printed because we start at index 1, and index 1 is the second element, remember? Okay, here. So then there is no end, so it just continues to the end of the list. However, if we say names, sublist, and we say go from 1 and to the index of 3, then you can see bar, baz, cox, and then we say bar, baz. So index of 3 is exclusive. So otherwise, the index of 3 is 0, 1, 2, 3. Then cox should have been included in that second iteration, but it wasn't. So the start index is inclusive and the end index is exclusive. All right, and you could also say go from start from the index of 2, and there is bar, baz, what was it, foo, bar, baz, so start with baz, and then stop at the index of 3. Okay, so it will just be baz. So let's see, there it is. Okay, I know it's also a little bit confusing. Perhaps we should put some separators between these. So let's put a print separator here, 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 and you can see the last iteration just prints baz to the console. Okay, now you can also have lists which you can modify. So lists are internally mutable. So you can create, for instance, a list in here. You can say final, and you can collect some people's ages in here. We can say 20, 30, and 40. Now you can mutate this list. Okay, we've already talked about the difference between final and constant. So this list is not a constant, only it is a final, meaning that this variable itself cannot be reassigned. So you can't just do this. Okay, but since it is a variable, it's still a variable list. It can be modified. So you can say ages.add, and we say 50, and then we can add ages.add 60 as well. All right, and then we can print the entire list in here, and of course a separator. So let's have a look. You can now see the result includes 20, 30, 40, and 50, and 60. Okay, so using the add function, you can actually mutate the internal contents of that list. You can also compare lists with each other with the correct ordering. Okay, so as long as you have the correct ordering, you can compare the lists. Let's have a look at an example. I'm just going to paste some contents in here. You can see it's the same exact content in both of these lists. And then we say if names1 is equal to names2, and we say print names1 and names2 are equal, else then we say they're not equal. And then of course our little separator in here. So let's have a look at the results. You can see we get names1 and names2 are equal simply because they contain the exact same contents. If they have some problem with like the casing, like this one was a lowercase f, and we saved the file, you can see that they're not equal now. And of course also if the ordering was not right, like if this foo was placed after bar, then we would get the same result saying they're not equal. So as long as the ordering of the list and the contents are exactly equal, then you can use the equality operator in order to compare whether two lists are actually equal. But this is usually something, I mean, you can sometimes need something like this, but usually when you compare lists, you kind of want to do it unordered. Okay, and we're going to have a look at how we can do that. Now, with lists, one of the most popular ways of working with them is to map them. Now, mapping is the functionality of going through a list, iterating over the items in a list, and then converting them perhaps to another value of the same time or another value of a different type. Did I say time? I meant type. So let's say you have an array of strings that are like foo, and then bar, and then baz. Okay, let's just say that this is our list. Now, if you map this, if you say map it, and then you get the strings in here, a string, and then you say str length. So what happens is that Dart says, okay, here's your list. You're mapping it. Then I'm going to go through the first item, through this list, starting from the first item. I'm going to pass foo in here, and then you're converting that foo to its length. So it's 3. Then I'm going to create another list and place that result in that list. Then I'm going to give you the second item, which is bar. You're again converting it to its length, which is 3. Okay, that will be another 3 in this list. And then baz, which is also having the length of 3. So the result of this operation in here is going to be a new list. Actually, it's going to be an iterable, but we'll talk about iterable soon, which contains the result of what you produced inside your map closure. Okay, so that's what map does. You could also convert it to the same type. You could say str to uppercase. Okay, and then the result will be foo, bar, and baz. Okay, so map iterates over a list and also allows you to convert that. It allows you to convert every item in that list to another value of the same type or another type. Okay, so let's convert these to uppercase actually, and then we will for each them, and then in here we will just print the results. Okay, so let's see what happens. You can see it says foo, bar, baz. They're uppercased. Okay, and also you can convert them as we talked about. Let's put these, let's instead of this say names. Okay, and so that we don't have to recreate a list in here. So, and then in the second example, we'll say str length. So now you can see 3 being printed is just because the original list actually contained names or strings, each of which was only 3 characters in length. Okay, so that's how map works. It's very powerful. It's one of the most used functions on lists or iterables. So I really suggest that you learn how to use them. Now, you can also, there's a technique using which you can reduce an entire list to a single value. Now, why would you want to do that? You might ask. Let's say that you have, I give you an array like this, and I'll say, grab its sum. So I'll say, grab the sum of all the numbers that are in this list. How would you go about doing that? Well, one way to do that is to go ahead and say, let's say final numbers. So let's put this in an array, and then we create a sum. Okay, so we say var sum is 0. Then we say for final number, let's get rid of the terminal in numbers. And then we can say sum is plus equal to that number. And then we print, a number in here. And then we say print the sum. All right. So let's actually reduce this to just 3 elements. And we can see the sum in here printed equal to 6. So this was quite a lot of code. You can see first the creation of the list and etc. And the creation of like an intermediate variable in here, and then summing them, going through the entire list. So there's quite a lot happening in here. What you could do though is to say, okay, I want the sum to be a final variable, and then I want to go through numbers using the function in here for fold. And what fold does is that it says, okay, first start with a value. We say, okay, we start with the value of 0. Okay, then the second parameter to this fold function, as you can see in here, says, okay, that start value that you gave me, I will take it as the generic parameter that you're returning. You can see this t, everything starts with this initial value. So if this initial value is an integer, the entire result of this fold is going to be an integer. Okay, so we started with 0, which is an integer. And then it says, okay, then after providing this integer, you need to provide a function that takes that value and a value which I can find within this numbers array. Since this is a list of int, the fold function already understands this second parameter to this closure is going to be an int. Okay. However, if this was like an array of strings, so let's say names, fold understands that this is the second parameter to this closure is going to be a string. Okay, but the rest are staying as t. So let's go in here and we say, okay, numbers, we fold it, we start with the value of 0, and then we need to give it a function, and this is going to be our int previous value, and the second parameter is going to be this value, and in this, then we say return the previous value plus this value. So let me just put some some commas in here so we can see the code a little bit better. So I'll explain how this is working. So we start with the value of 0. This 0 will be passed to this parameter by default function for you. And then it will go through the elements inside the numbers list. And it says, okay, I will grab the value of 1 and I'll put it here. Then it says, okay, we start with 0. And then the first element in this array is 1. What do you want to do with 0 and 1? You say, okay, 0 and 1 plus each other is 1. Then the result of this statement will then be placed here in the next iteration. So it will say, okay, I'll give you 1. And then the next element in the element is 2. What do you want to do with 1 and 2? So, oh, we want to plus it. So it'll be 3. And then it says, okay, I'll put 3 in here. And then the next time I'll look at the next element in the array. I'll give you 3 in here from your previous allocation or from your previous expression, and then 3 in here as well, because that's the new element. What do you want to do with it? 3 plus 3 is 6. So then the sum is going to be 6. So this is how fold works. It kind of goes through the list for you, gives the elements one by one to you, and it says, okay, given the previous calculations that you did and the new value, what do you want to return? Okay, so using this technique, you could literally go ahead and, for instance, grab the length, the entire length of a list of strings. So let's say in here that we want to grab the entire length of all the strings in this list. So this is 3, 3, 3, 3. So we should end up with a value of what will be 12. Yes. Wait a minute, 3, 6, and yes, 12. So we can use a fold as well. So let's go ahead in here and put a separator like this here. And then we go and say, okay, we want to fold that names. We say fold it. We start with the length of 0, okay? And then we say previous, or we say total length. And then in here we say str. And then we say get the total length and plus it the str length. Okay, and we say final total length is equal to that. Let's put some commas in here to get the formatting right. And then we can print this to the console. So we say print total length and a little separator as well in here. Let's see if we can get it right for us. There we go. So there you go. The result of 12 is passed in here or printed in here. Okay, so fold allows you to reduce, or it allows you to kind of like produce one value for an entire list. Okay, so that's how fold works. And in some other languages, it's actually called reduce, this function. But it works a little bit different in here because there's also a reduce function. Okay, now you can also reduce a list to the same type. Okay, so let's say that you want to, for instance, kind of convert the entire list of names. So if you have this, you want to convert it to this string, foo, bar, baz, cox. This is what you want to do. All right, so you could fold the list. Let's go ahead in here and we say final result, and then we say names, fold. We start with an empty string. So then we go in here and we say, okay, the result and string. Then we say, okay, we want to grab the $result and also a space $str to uppercase. Okay, let's see what it is complaining about in here. We have to close this. Okay, comma in here, and then I'll put another comma in here so we can look at the entire result. So what happens is that we start with an empty string. That empty string will be passed in here, and then we say a space. Okay, and then it will be, okay, to uppercase, the next element. So it will be, what is it, foo? Yes, so it will be empty string space uppercase foo. Then that will be passed to result, the next iteration, and then bar will be uppercase. So you can see how this could result in a string where all the elements in the list are uppercase. So we can say print result, and the result will be printed in here. So you can see we basically have a little problem since we have an empty space in here, simply because we didn't take care of a situation where basically the first element is passed in here and we have an empty string. But you can fix this if you just put your head into it. Okay, maybe that could be a little good homework for you. So how do we get rid of this first space, which is the result of appending a space to an empty string in the first iteration of this fault? So that could be something nice for you to fix. We've talked a lot now about lists. These were some of the most fundamental functionalities of lists and how you can use them. But from this entire chapter, I would say from this entire example, if there's one function that you're learning, let that be the map function, because it is very, very useful. It's one of the absolute most useful functions that you can find on lists in Dart or pretty much any other programming language that supports lists and mapping. Okay, let's close this example and then we say we have an example 2 in here. Oops, dirt. I don't think it's a dirt file. Let's change this to a Dart file like this. And of course, fswatch, we have to fix that as well. Let's say fswatch example 2 and a main function. Okay, so in this example, we're also going to talk about collections, but we're going to talk about sets, which are another type of collections. Okay, and in here, we're actually going to use our first package, and we haven't done this before. So packages are basically pieces of programs or libraries that people have created for us, and they've published them somewhere. Okay, so let's have a look at how we can actually do that. Let's go ahead in here in our terminal. I'm going to create a new terminal window or a new shell in here, and you can grab packages using a special command. You could say dart pop add. So anything you type after this, it will be the name of a package which should exist somewhere. And that somewhere is on a website called pub.dev. Okay, so packages for Dart and Flutter are published on this website. And if you go in there, you'll see a big search field. We could have a look at it actually. So let me see if I can bring up a window in here, and you can see this is pub.dev, and you have this big search field. And in here, you can type the package that we're going to use, which is called collection. Okay. And you can see it is Dart collection right here. And if you go in there, you'll see, I think there should be some instructions on how to add it as well, but maybe there isn't, unfortunately. So how we're going to add this guy is using Dart pop add, and then we say collection. All right. So you can see in here, it's going to do its work, and it got the dependencies, and these dependencies are then going to be stored inside this beautiful file, which is called popspec.yaml. And now you can see that we have a dependency on the collection package. All right, now that you have the dependency, you need to import it into your Dart file in order to be able to use it. So we say import Dart collection like this. Okay, and that means literally you've just imported it. Actually, no, not that Dart collection. We actually want to get the package of collection like this. Boom. Okay, so a collection package, not the Dart collection. All right, that's already imported into the standard library. So I actually wonder when we looked at pub.dev if we were looking at the wrong package. So let me bring it up here again as well, and let's just type collection in here. And that's Dart collection. That's not what we want. This is what we're talking about. So this is the one that we're talking about. So let's go into installing, and you can see it tells us that Dart pub add collection. This is pretty much what we've done. So sorry about that. This is the one that we looked at first was the one that's already in the standard library. Okay, in the core library. So this is not what we're looking for. This is what we're looking for. And the installation instructions are actually written here somewhere, installing. Okay, so this is how you bring a package into your application using Dart pub add, and you can also say Dart pub remove in order to remove a package. So it's just a little bit confusing about this particular package since it's called collection, and also Dart has a collection package built into its core library. So that's where the confusion actually came from. But don't worry about it. Now we have this collection, and we are getting a warning because it's telling us that we're not using this guy. So what we could do is to comment it out for now until we need it. Okay. Now let's talk about sets because they're also very, very useful collection types in Dart. So what sets are is that there are a collection of values in which any value which is seen to be equal to another value using some particular functionality and mechanism cannot be repeated twice. Okay, so it is like a unique list kind of values. Let's create a set then. We say final names and we say it's a set, and then you do that with these curly brackets. Okay, and in here you say foo bar bascox, and then if you look at the data type, it is a set of string. If you change the curly brackets to square brackets, then it will be a list of string. But if you change this back to curly, then of course it will be a set. Okay, so what happens in here is, I mean, you don't see anything different. It's just, let me close this shell as well and save this file. And we're not printing anything to the console. You can print the names, actually say print names. Okay, there we go. You can see foo bar bascox. However, if before here you said names, add another foo in here like this, and then you print the results, you can then see foo is only in the set once. So by adding foo, you can just add it hundreds of times. It still will be one instance. Okay. However, if you change this to a list with square brackets in here, then foo will have been appended to the end 3 times. Okay. So sets somehow magically, which we're going to talk about soon, understand that a value is duplicate and it cannot be placed inside the set again. Okay. Let's create a little separator and we'll talk more about this soon, like that. Okay, now you can create sets using a special operator in Dart called a spread operator. Okay, so let's say that you have final names 2, and then we say foo bar baz cox, as you can see in here, or perhaps maybe not, let's not do that. We say foo bar baz and then another foo. Okay, this is a list, and therefore it can contain duplicates. However, if you want to create a set out of this, then you can do that using the spread operator. Now you would be asking, why would I want to create a set out of this? Well, one very, very important use case for this particular case is that someone asks you, here's a list of strings, get rid of all the duplicates. Now, if you didn't know about this spread operator and sets, then you'd probably create some crazy loop over this array and then add the items into another array if they don't already exist in that second array. So this is like a typical way of writing such an algorithm. But there's another way of doing that, and you could say final unique names, and then you say, okay, I'll put this guy in a set, but first you have to spread it and say names too. Okay, and you could try it with this in here, and let's actually see what happens. Okay, you'd be surprised. So let's say print unique names, and then we put a separator. And if you look at the data type for this guy, it's a set of a list. So if you in here, then you said names 2 again, and then you print the results, you can see the result is a set whose first element is a list. But it doesn't have a second element because the second element was the same list. So these two lists are considered to be equal. Therefore, it can appear only once in this set. But this is not at all what we wanted to do. We didn't want to put an entire list as an element of the set. We want to actually extract every element inside this list and put those in the set. And that is why you need the spread operator. What this spread operator does, as its name indicates, it spreads or extracts every value within a collection and puts those values within another collection. So now we have foo bar baz foo. It's as if you took these values and spread them in here. This is pretty much what the spread operator is doing. Okay, so let's have a look at the results then. You can now see the result of this is foo bar baz. Okay, so actually we're not printing the names 2. Let's print names 2 as well. Names 2. So you see what names 2 includes is foo bar baz foo. Foo was repeated twice in that list. However, when you spread it into a set, you're pretty much getting rid of the second instance of that foo string. Okay, so this is a very, very handy way of getting rid of duplicate values within lists using sets and spread operator. Okay. Now, sets work with hashable objects. Now, this is something that is super important to understand in Dart or any other programming language that has support for sets. And that includes Rust, includes Swift, includes TypeScript, it includes Python. Every modern language pretty much has support for sets. So you really need to understand how hashing works, because that's pretty much the basis of how sets work. So let's have a look at an example. Let's create, before I explain hashing, let's have a look at an example here. We say final foo1, and we say it's equal to the value of foo. And then we say we create a variable called foo2, which is equal to also foo. Let's print foo1's. It has a property called hash code. You can see it, I think it returns an integer. Yes. And then we say foo2, get the hash code, and then print the separator. Okay. Now let's have a look at the results. You can see it prints an integer, well, that we didn't provide, but it is this integer, which is the same integer for both of them. If we change this to a lowercase f, you can see the hash code is changed. But as soon as it is the same exact value, then the hash code is the same. Now, this hash code together with equality determines whether a value can appear in a set twice or not. Okay. Now, a lot of people think it's just hash code, but it is not, because hash code together with equality determines whether a value can appear more than once inside a set or not. And we're going to talk more about this soon, but in order to do that, we have to create some custom classes and kind of calculate their hash code, so I can demonstrate this a little bit better. But just for now, know that hash code is like a special integer value using which sets understand whether a value can appear more than once inside the set. Okay. Now, if you have sets, you can also check whether they include a value or not. So you can say if names, which, if you remember correctly, it is a set of strings. Then we can say if names contains the value of foo, and this is exactly how you would do it with lists. They have the same exact function. And then we can say else did not find foo, like this, and then we can have a look at the results printed to the console. It says found foo. Okay, so contains is a function that's available both on lists and sets, and you can use that in order to pinpoint a value or find a value within that set. Now, equality in sets is not going to work as you'd expect it. So let's go ahead in here and create two sets, and I've already prepared those two sets so we don't have to type them. So you can see there are two sets that contain the same values. And if you say if ages 1 equal to ages 2, then we print something like that. Ages are equal, otherwise we say ages are not equal. But you can see in here it says ages are not equal, but they contain the exact same values. Now, if you converted these to lists, you would probably think, they probably are going to be equal, but unfortunately, they're not going to be equal even then. So let's convert these to lists. So, and then run the application again, and you can see ages are not equal. So there's some magic happening in here, and I'm going to explain this more soon, because what is really happening in here is like it's comparing the instances of these, since they include values that are really not the same instances, and the lists are not the same instances, then they're not considered to be equal. And this is something that we go a little bit deeper into later, and that is like doing a comparison, like deep comparison of the contents of lists and other types of collections. But just for now, know that you can't do comparison like this between all sets and all sorts of lists. Okay, so let's move past this, and we put our separator in here. So just know that you cannot do this type of comparison between sets usually. Okay, and we'll talk more about how you can actually do that. All right. Now that we've added our collection package in here, let's uncomment it, because now we're going to talk about how you can actually do comparison between these types of sets. So if you want to do a comparison between these two sets, then you have to use a class in here, which is called set equality. Okay, set equality. And this comes from the package, the collection package. You create an instance of it, and then you say equals it has a function that expects two sets, and then it will give you a Boolean value if these two sets contain the same values. So we say if here, and then we say print ages are equal, otherwise ages are not equal. And then if you look at the result in here, it says ages are equal. Okay, and now you can go ahead in fact and change like the ordering of these values, and still the collection package will tell you that these are equal, even though the ordering of the values is different. So this set equality, you can read this documentation actually, it will do like a deep comparison of the contents of that set, and it doesn't, it's like, it's not taking care of like their index. So is irrespective, I would say, it's irrespective of the placing of the elements inside those sets. Okay, so it's a very, very handy class which you can use in order to do deep comparison, regardless of the placing of elements inside sets. All right. Now, let's put a separate example in here, just to demonstrate that set equality is unordered. So it's irrespective of the placing or the position of the elements. So let's create an ages3 variable, which is similar to ages1 and 2. It's just not the same order of values. Okay. And we place it at the end in here. And then we do the same code. We say if set equality, blah, blah. And in this case, we compare ages 1 and 3 with the new ages3 variable that we just created. And then we can see the results. It will tell us that ages are equal. Okay, so this was just to demonstrate what I've been talking about for the last minute or so. Good. So I think this is actually enough for sets. Let's now talk about how sets actually work internally. All right, let's close this and we go to example 3 Dart. Because I mean, it is nice to keep talking about sets and just look at them at surface level, but it is, I think, even better if we see how sets really work and why is it that sometimes they allow a value, like they allow duplicate values to be presented inside of them, and that's simply because of hash code and equality. So let's go in here and we go into fswatch, and then we say example 3 Dart. Good. And then we have a main function, and we don't need our terminal right now. Let's create a person class in here. We say class person, and this person class has two properties. It has name and age, and I'm gonna make these required named parameters like this, required, and a comma in here. Now you saw that I just pressed Command S on my computer, and all these parameters were just added for me. And also I have a little tool in here which allows which creates the constructor for me. So as soon as I add these final parameters in here, you can see I can just press Command S and a constructor will be generated for me. And this is just something that I've done in my I think it's in user settings. For Dart, you can see I have a few quick fixes, and these are just like, it's an engine that sits in, and every time I save, format on save, you see is equal to true. These things, sorry, actually this has nothing to do with the save, I think, in here, but you can see code actions on save. So every time I save my code, all these quick fixes will kick in. All right. So the add required works in that if I go in here and put curly brackets here, then if I press Command S, it adds the required keyword one by one to these parameters. And you can actually pause the video where I showed you all my quick fixes, and you can place them inside your own JSON settings as well, okay, to get all these benefits as I'm seeing here. Okay, so let's go ahead inside this person class and override the toString function so that every time we print an instance of our person, then it will tell us which person that is. So we'll implement toString like this, no return in here, and we say person, and we say name and age like this, name and age, boom, boom. All right, so that's our toString. Now what we're gonna do is to go ahead and implement two very important functions in here. Actually, one, they're not really functions. One is a getter, the other one is an operator, but they're kind of like functions, I would say. So the first thing is, if you're creating an instance of a class in here, which can be placed inside a, let us say, it can be placed inside a set, then you have to ensure that you implement the hash code getter. Let me just explain what's happening. Let's create two instances of this class. All right, so we create two instances of this class like this. Oh, we don't have a dog. Let's just say person2. We say person, and then we say person1, and then person2. And then we say person1 print person1 hash code, because we haven't implemented hash code. Let's just see what the default does. And then we say person2 hash code. Let's just see the results printed to the console. And you can see that they're different. Okay, so what happens then is if you go ahead and create a set, so let's say final persons, and then you create a set of person1 and person2, and then you print this set, you would probably expect for this set not to include both of them, because you can see the values are the same. This is saying age 10 and foo and 10 and foo. So how is it that they can be both inside the set, even though they contain the same values? You can see now you have duplicates inside your set. So just because the contents of a variable are the same or are seen to be the same, it doesn't mean that sets automatically understand that. And the reason behind this confusion is that we haven't implemented hash code in here. So let's go ahead and implement hash code. So we say we are overriding a getter, and we say int get hash code in here. Okay, and what we need to do in here is to generate a hash code, and the easiest way to do that is using object.hash. All right, in here we pass it an array. We say hash these the name and the age. All right, so now we've done that part, but quite correctly, Dart is saying that, hey, you're implementing hash code, but you haven't implemented equality. So hash code and equality are basically going hand in hand. So just because the hash value of an object is the same, it doesn't necessarily mean that it is considered to be equal. You can see we've implemented hash code. That's great. Okay, and if you print these two persons hash codes, like say print person1 hash code, and you can print the other person's hash code, they're the same. They're the same integer, but simply because they're the same integer doesn't mean that person isn't going to appear twice within a set. So in order to get that part working, you need to also implement equality. So you need to compare two instances of person and see whether they're equal or not. So let's say create this method for us. There we go. Now, equality is a little bit special in Dart in that we have to actually compare a few things. And the first thing we usually do is to call the identical function. So we say this Boolean is true if these two objects are considered to be identical. So this and the other. So if these two are considered to be identical, meaning that like person1, you can see in here, and if I said person2 is equal to person1, then person2 and 1 are identical, because person2 literally just took the value of person1, so it's identical. Okay, now that's one part, but if that is not true, then we should say, okay, or the person or the other object should be a person, and the other and the runtime type we could also compare. I'm not actually sure if it's required, to be honest with you. I think the runtime type is not required. Then we say, and the name of the current instance is equal to the other name, and the age of the current instance is the other age as well. So either these objects are identical, or the other object is a person and they have the same name and the same age. Okay, so then if you look at the results now, you can see there's only one instance of this person inside our set. Okay, so let's go ahead now and create the exact same class, and we call it dog. All right, so let's copy the person class here, and let's copy the entire contents, and then we paste it in here. Let's change its name to dog, and then the constructor to dog as well. And then here we say it's a dog, and everything else is the same except for equality, where the other should be expected to be a dog as well. All right, so that's exactly what we needed to do. Then we go ahead and create an instance of this dog. All right, so let's go in here, and instead of this person, we place dog in here, and let's print their hash code. So we say print the person's hash code, and then actually perhaps we could change this to person, and then we print also the dog's hash code. So we say hash code in here. Okay, now you can see then in the console they have the same hash code. But why? You'd be asking, but why do they have the same hash code? Well, simply because if you look at the implementation of our hash code, it's just saying object hash, name and age. As long as the name and age have the same value, regardless of which class they're in, then their hash code are going to be the same. That's why these integers are the same, because that both the person and the dog have the same age and name. All right. That's why the hash code is the same. However, their equality is not implemented the same, because their equality for the person class is making sure that the other object is a person, and the equality for the dog class is making sure the other object is a dog. So if you then place these two inside a set like this, like a being is a set, or you could just call it things, and if you print that set, you can see in here that you can see both person and dog in there. Okay, and that kind of makes sense. But if you place the same person in here, like let's just say final person2 is equal to person, and then put that person2 in here, like person2, and if you print the results, there's only one person in here. Okay, simply because person1 and person2, sorry, person and person2 are considered to be the same, because the equality is checking identical here. Okay, and if you could check identical yourself as well in here, let's see, we say print identical person and person2, and you can see the result of this is going to be true. There we go. Okay, so since those two are considered to be equal to each other, then they can't appear in the set as long as they can't appear at the same time in the set as long as they have the same hash code as well. Okay. So hopefully this helped clean up some of the confusion about how basically sets work in Dart. Okay, I feel like we've now talked quite enough about sets. Let's move on to using maps. So I'm going to close this file and let's create example for Dart and a main function as we usually do. And then we go ahead and we say fswatch example 4 as well, and we can save the file and start working with maps. Now, maps are something that you probably are familiar from before, and there are key value collections. So you have a key, and for that key, you specify a value, and the keys need to be unique within the map. Okay, and whenever we're talking about unique, just keep in mind the sets, keep in mind the hash code, the equality, that kind of determines whether an object can appear as a key within a map or if it's going to be a duplicate key. Okay, so keep that in mind. Let's create a dictionary here or a map, and we say final info, and we say you can see in here maps are also created with curly brackets, but then you'd be thinking, oh, but wait a minute, that's how we create sets. Yes, but sets don't have keys and values, they just have values. So if you go ahead in here and say a key of name has a value of foo, and a key of age has the value of 10, then this is a map of string and object. Okay. However, if you didn't have these columns in here and instead had like this, then you had a comma, then this will be a set of string, right? But since we have these columns and equal, a name, a key in here and a value of foo and etc, then I don't understand that this is a map. Okay, now you can print this map. Let's just say print info, and also you can grab values out of this map. You could say I want the value for the key of name, so you can say print info for the key of name, and you can also say age. All right, and also then we can put a little separator in here so we can continue to the next example. So if you look at the results, you can see the entire map is printed. The value of the name key is foo, and the value of the age key is 10. All right, so that's how you would usually use a map, using basically you're subscripting its keys. All right, now you have access to the entire map's keys and values. So if you say print info.keys, you can see it's a list or iterable of strings, and in here we say values, and then of course our little separator in here. So if you say give me all the keys, it says its name and age, and all the values are foo and 10 as well. Okay, you can also add a key and an associated value for that key to your map only if that key doesn't exist. Okay, and I mean, sorry, I didn't mean to phrase it like that, that you can do that only if it doesn't exist, but I mean, if you want to add a key to a map only if that key doesn't exist, then you can use this technique. You can say info dot put if absent. Okay, so you put a key, let's say put a key of height, and then in this function you produce the value that you want to place in it. You would say 180, for instance. Okay, and then once you do that, then you can print your info. You can say print info like that, and then you would just we could just print our separator like this. So if you look at the results, you can now see name, age, and then height is available in there. Okay, and if you do this twice, let's say you first put if absent, and then you put if absent 190. You can see 190 is not present in our map simply because this key was not absent. It was present actually. So this function didn't do anything. All right, so let's just remove that. Okay, now if you don't care whether a key exists before you place a value in the map, then you could literally say info height is 190. Okay, so you're literally saying that that key's value should now be 190. Okay, and then you can print your info and a separator. Then you can see the value of height key has been modified to 190, regardless of whether height existed or not. So you could actually comment this line out where you put the height in the map, and you can see now height is 190. So this code works even if height doesn't exist from before within the map. Okay. Now you can also iterate through the entries within a map. However, since Dart yet doesn't have tuples, the syntax is a little bit strange. So you would say final. For, you create a for loop for final entry in info.entries, and you can then see you will get every entry is then a map entry, and then you would print its key and value. All right, so the keys and values are then going to be inside this entry. In some other languages in most languages nowadays that they have support for tuples, you could say key and value for like key and value in something, and then like this, and then you could print the key and the value. It's just a lot less good in most other languages, but Dart doesn't have that feature yet, so you have to go through its entries, and every entry is a map entry which has a key and a value. Okay, and you can print them to the console. You can see the results. Name is foo, age is 10, and height is 190. Okay, let's put our separator in here now like this. Now, for the next example, if you want to test whether a map contains a key or not, then you can use a contains key function on it. So you could say if info.contains key, and your key is height, like this, then you could say print height is, and then you can grab that value and place it in here. And otherwise you can say height is not found. All right, let's see the result. You can see height is 190. Okay, so using contains key, you can check whether this map contains that particular key, and then you can grab its value, as you can see, using this subscript, which you can see in here. Okay, good. So that part is done now. Now you can also try to retrieve the value of a non-existent key, and that will just return null to you, so it won't crash. So if you try to say print info, grab the weight, okay, since weight doesn't exist, let's actually put a separator in here as well, print like this. You can see then you get the value of null printed to the console, and we could put a separator, I think, here as well, just so that these two examples are separate from each other. Okay, so if you try to grab the value of a non-existent key, then you get the value of null. Okay, now maps don't necessarily have to have keys and values of type string. They can pretty much have the keys and values of any type. Okay, so let's create a map with integer keys, for instance. We say final map with int keys, and then we say the key of 10 has the value of 20, and the key of 30 has the value of 40, just for demonstration purposes. And we can print this guy and a little separator in here as well, like this. There we go. Now you can see the map is printed to the console. You can see the key of 10 has a value of 20, and etc, etc. And of course you can extract, you can say, like, for instance, print the map with int keys with the key of 10. What is this value? And it will give you the value of 20. as you can see in here. Okay, so that's short and sweet about maps. Now let's go to the next example. We say example5.dart, create a main function, and then we'll do a little fs watch in here with example5. All right, now let's talk just quickly, just a short introduction to iterables. Iterables are lazily evaluated lists pretty much. So what happens is that let's not say what happens. Let me instead show you an example. Let's say we create an iterable, and we say it's equal to iterable.generate. We've already seen this before. We say give us 20 values, and then the second parameter that you can pass to this iterable, so you can either do this, or if you look at the signature for generate, it has an optional parameter in here, which is called generator, which will give you these values that it has generated, and you can pass a value out of this, and this value that you pass out of this closure will then be returned inside your iterable. So let's go ahead and create it, and then we say the index for any value that you create from 0 to 20 exclusive. We want to create a function in here. We say string get name, and then we say an integer, okay, and then we say print get name got called, and then we say return John number, let's say $I. Okay, so it's just a function that returns a string, and every time we get a new integer from our generate function, then we call this function and we say take the integer and generate a name. So the first time the I value in here will be 0. 0 will go into this function, it will print this statement, and it will generate John number 0. Next time 1, 2, 3 up until an inclusive of 19. All right, so now it's an iterable, right? So if I say print iterable, let's see what happens in here. Now you can see it says get name got called 1, 2, 3, 4. Okay, and all of these are called in here. There we go. Okay, so you may be thinking, but wait a minute, that's pretty much just like what lists do. So what's the difference in here? Now I'll show you what the difference is. Instead of printing this iterable, let's just say we say for final name in this iterable, and then we say take only 2 of them. Okay, so this take function, what it does, it grabs only 2 elements out of this iterable. So if we then print this name, let's have a look at the results. Let's clear the console and Command S. Now you can see our function got called only twice. But what happened here? Wait a minute, we created 20 values, and for every one of those we're calling this getName function, but our getName function was only called twice. It has definitely something to do with this take2, right? But it doesn't have only to do with the take2. It has also to do with the nature of iterables. So what iterables do is that they're lazily evaluated and they're lazily generated kind of. So this iterable in its generation, like this function, is not even called until you start using this iterable. And when you say take2, you're literally saying, give me 2 of those lazily generated values. And when you iterate over those 2 elements, it's only then the values will actually be generated and passed to this. So the first value will be 0, and the next value will be 1, and then it's done. That is the reason this function is being called twice. So just remember, iterables are evaluated lazily, and that is the difference between iterables and lists. Lists are not lazy collections. They're generated all upfront, but iterables aren't. Okay, let's go to the next example, and this is going to now mix iterables and lists. So we create example 6, I believe, Dart in here, a main function, and fswatch example 6 as well. All right, so let's create a list of names. All right, and then what we're going to do is to map these names to uppercase. So we say final uppercase names is names, then map them. And then in here we say name, and then we create a function with curly brackets. In here we say print map got called. All right, and then we return the name to uppercase in here. There we go, and there we go. Now this is an iterable of string. What happened? Wait a minute, names was a list of string, but this is an iterable of string. But now that you know iterables are lazily evaluated, have a think about this. Does this make sense? Why is it iterable. And why is this not a list? Well, the reason behind this is that Dart says, wait a minute, you may be doing some heavy calculation in this map. Do I really want to call this map for every element? Or do I want to call this map for every element of this iterable that you actually consume? Because remember, someone can go ahead and say take 2 or take 1 on this result. Should it really call map on every element if you're only consuming 2 or 1 elements? No, it shouldn't. And that's why it's that's why it's returning an iterable. So anytime you're seeing an iterable, just know that it is trying to be smart, and it is actually smart. It's trying not to waste any resources on doing unnecessary calculations like this one if the only thing you're going to consume is 1 element out of this iterable. Okay, so then we say for final name in uppercase names, and we take only 3 elements instead of 4. Okay, and then we print that name. Let's have a look at the results. You can see our map got called function. Map got called print statement is only printed 3 times, not the fourth time, simply because we're only consuming 3 elements out of this iterable. Okay, so that's for example 6. Let's go to example 7 in here, and then we will create also a main and fs watch that as well. So let's say example 7, boom. All right, so let's create a list of names like we have here, John, Jane, and Jack. All right, now in Dart, if you want to protect your lists from being modified, then we use something called unmodifiable list views. So this also comes from our collection package. So let's import that. So we say import Dart, not Dart, we say package collection, like this, and then we import the entire collection package in here. And then what we'll do is to go ahead and say we create a read-only list out of this. So we say read-only list is equal to unmodifiable list view of those names. And then if you go in here and say read-only list dot add the value of Jill in here, then you'll get an exception printed to the console. So have a look in here, you get this exception: unsupported operation cannot add to an unmodifiable list. Okay, so and this is just something that Dart has created so that because if you pass lists around, then someone can modify them, but if you pass unmodifiable list views around, then no one can modify them really. Okay, so let's go in here, and then we will put this inside a try like this, and then we can catch our exception and perhaps print that to the console. So if we run our fs watch again, then we can see the exception is simply printed to the console. So the goal of this example was just to demonstrate if you want to create a read-only version of your lists in Dart, then you need to use unmodifiable list view. Now let's move on to the next example. And now we've looked at unmodifiable list view. Let's have a look at its counterpart, which is unmodifiable map view. So I'm going to create example 8 in here. Let's go ahead and say example 8 Dart main function, and of course fs watch on example 8. Okay, let's create a map view in here. I'm not going to create the map view itself. I'm just going to paste it in here simply because the creation of the map is quite a simple task that we shouldn't probably spend so much time on. Now, if you want to create an unmodifiable map view out of this, first we have to import our package, which is the collection package. But otherwise, if you're using Visual Studio Code, it can auto import it for you. So if you say final info2 is unmodifiable modifiable map view, in here you can see it will be auto imported here on top. Okay, so you don't have to do it yourself, and we can create that out of this info map right there. So once you do that, if you go to info and you say info add all, okay, so you want to add another map to the info map. So let's just add this map, you can see. Okay, so we can try to print this. We say print info, all right, and that will work beautifully. So we just added a phone, an entire map whose only key was the phone key, which is added right here to our info map. So we added one map to another. But if you try to do the same thing to your info 2, then you will get an exception. So let's try that. So we put this in a try, and then we put a little catch in here, and we print that error. or exception. And we'll do the exact same thing that we did with info, but this time around we'll do it with info2, which is unmodifiable. Okay, and we have a look at the results. You can see unsupported operation cannot modify unmodifiable map. Okay, and you can now guess it. Then they're unmodifiable views pretty much for all the collections. Okay, and what they're really useful for is, you may be thinking, but why are we doing this? Like, what's the point of this? Well, the point of this is that if you have a class, for instance, and that class exposes a list, anyone can go and access that list and add stuff to it. You don't want that. So it's for encapsulation purposes. If you have a class, you should hide its arrays or lists behind unmodifiable list views, or its maps behind unmodifiable map views. So let's have a look at an example. Let's create example 9 in here. Example 9, Dart file, and let's just fswatch our example 9. We can hide the terminal for now and create a main function in here. Okay, so let's create a person class. Let's say class, oopsie daisy, class person, and we say final string. It has a name. Okay, and then let's say that every person can have a list of siblings. So let's say final list of person, and it's an optional, and it's a private field. So we say siblings. It's private because we don't want to expose an entire list to the outside world. Okay, now unfortunately Dart doesn't have real private properties like other programming languages have. Like Swift has a private field, and it is truly private to that class. However, this still is accessible by the outside world. Like if I say person is a new instance of person in here, and we say person, you can see this property is still accessible. Okay, however, that's just something we have to live with. Okay, now that we have that, let's go ahead and create a constructor in here, and like this, and we make these, actually let's make this guy required like this, and this guy then is going to be optional. Okay, so we just say we have that, and then we take a list of persons like this, which is optional, siblings, and then in the constructor we say our siblings is equal to the siblings that you pass in here, and we make this guy a constant as well. All right, a little comment here to get the formatting right. Good. Now what we want to do is to not let this guy access our persons and add to and not to be able to access the siblings and add stuff to it. Because if you go in here and we say person is equal to, let's create an instance of this person like this. Let's go and create an instance. Let me paste it in here. You can see it's a person, and its siblings is an array of another person. Okay, now if you went in here and said foo.siblings, then you could just add another person to this. Okay, and Dart will just comply and be like, this is fine. You just add it to the siblings. But if you expose a siblings array that is unmodifiable from this class, then the caller won't be able to modify it, of course. So let's create a getter for this class, and we just say it's the return value of this getter is unmodifiable list view. Okay, list view of person, and it's optional, and we call it get siblings. And GitHub Copilot is really trying to finish this. And I'm gonna let it do that because it's just, otherwise it's gonna drive me crazy. So let's import package collection, and you can see what it did in here. It's just said, okay, you're trying to create an unmodifiable list view. If siblings is null, then I'm going to return null. Otherwise, I'm going to create an unmodifiable list view out of that. Okay, so this is pretty much what I wanted to do. So I'm just going to let GitHub Copilot do its work. So let's go in here and test this. So we say try, and then we put it inside a try and catch an exception and print the exception as well. And then let's go ahead in here and say foo.siblings. This time we're going to use this getter of siblings, and then we say add a new person in here with the name of Baz. Okay, and a comment here to get the formatting right, and here as well. Now, if you look at the output, you can see an exception printed to the console saying unsupported operation cannot add to an unmodifiable list. So if you have lists exposed from your classes, it's best to hide them before inside unmodifiable list views, or if you have maps, unmodifiable map views, and as you can guess, unmodifiable set views as well. Okay, so that's basically how you would use these unmodifiable classes. So let's close example 9 and create example 10 in here. Okay, so let's have now a look at at an example which is quite complicated, but I think we've made it this far, and we can basically have a look at a custom list perhaps. So we haven't done this so far, to be honest. We've only used like list from the standard library. But if you want to create your own lists in Dart, you can follow this example, which we're going to create now. So let's say watch example 10. Okay, so let's go ahead and create our own list. We want to create a new list, type of list, that we call a safe list. The purpose of this safe list is to fix a few problems that normal lists in Dart have. Okay, let's have a look at these examples. Why the default implementation of list is not as safe as you might think it is. So let's create a main function in here, and we say final names, and then we say is a list of string, and it is equal to an empty list by default. Okay, now if you go ahead and say print names first, then you run your application, you crash immediately, and it tells you unhandled exception, no element. Oops. If you did the same thing with the last element, it will give you the exact same error. Okay, there we go. And here, unhandled exception. There it is. Okay, cannot, oops, it's not that one. It is no element again. So first and last properties are not going to work on empty lists, so it's not so safe to call them. In some other languages, such as Swift, the first property of a list is an optional value. And Dart has support for optionals. So I don't really understand why the Dart team has created this property as a string instead of a string optional. And I've talked to some people who are basically working at Google, and the reason behind this is that they want to change this, but it is too big a change, because in the beginning Dart didn't have support for optionals or null safety, but now that it has support for null safety, it is too big a change to go in and change these properties to optionals. In my opinion, I think sometimes breaking changes are required, and a modern language shouldn't be infested with bugs like this. Some other languages were brought to my attention, such as Kotlin. They have the same problem. However, I think no one really compares Dart with Kotlin. Dart is mainly we're basically comparing it with languages such as Swift or Rust, like modern languages, TypeScript, stuff like that, JavaScript. So I think it's best to convert these perhaps to optional strings once and for all and fix this issue. However, this is probably not going to happen, but we can go ahead and create our own lists. Okay, so we can create our own list class. Now, the other problem that lists have is if you, for instance, in here, go ahead and subscript them at an invalid index. So this names one, for instance. What happens if we try to access the second element inside this list and it doesn't exist? Let's run our application, fswatch, and then run our application. Then we get another crash. So pretty much everything that we're doing with this list is going to crash now. Okay. However, we could go and fix all of these by creating our own class. And that's exactly what we're going to do in here. So let's create a class in here, and we're going to call it safe list, class safe list. And it's generic class, of course, and it extends ListBase. Okay. And it's coming from Dart collection. And then we say T in here. So let's go ahead and implement some of the functionalities that we need to implement in order to extend this list base. So I'm going to get help from Visual Studio Code, and it's going to create 3 missing overrides for us. Okay. However, before we do all these overrides, let's take care of some of the inputs to this class. So what is this class going to work with? In the cases where we have an absent value, so let's say that you're trying to access the first element of our list, but it doesn't exist, then we need some sort of like a replacement value to return to you instead of crashing. So let's call that guy an absent value. So we say final t absent value like this. Okay. Now, if you also try to change the size of our list, let's say that we have 3 elements in our list, and then you change the length of the list to 4, then by default, we're going to populate our list with that particular value, and we're going to call that default value. Okay, so final t default value in here. And also, then we're going to have an internal list, which we keep all our values within. So let's say final list of t in here, like this, and then we call it list. This is a private list. Okay, let's create a constructor, as you can see in here. And then we're going to do some shuffling around. So let's bring this default value first. Then we're going to have the absent value next. And then we're going to have an optional value in here. We're going to say list of t is an optional, and we say values. Okay, so you don't have to pass this actually to us. Let's put all of these and make them name parameters, but only the first two are going to be required name parameters like this. Okay, and what we're going to do is to say that these two are directly linked to the this parameters, but this one isn't. So let's go ahead and say our private property of list is equal to either this values that you pass to us or an empty list. Okay. And let's see what it's saying. Non-nullable instance field length must be okay. We're going to fix that soon, so don't worry about that. Now, for the length in here, we are going to say int get length. So it's a getter, and it's going to return our list's length. Okay, so that part is fixed, and you can see our constructor is also fixed because of that. Okay, so let's go ahead and now do these implementations. So it's an operator, it's a subscript operator, which should return an element at that particular index. Okay, so how do we do that? We want to fix this default implementation, because remember, the default implementation crashes if you don't have this particular index in your array. So what we're going to do is say if index is less than the list length, then return that element. Otherwise, return the absent value. Okay, and also in here, this subscript, which is trying to assign a particular value to a given index, this implementation is going to be quite fine. So we're just going to say add that value to our list at this index, just like that. So that part's also done. We've done the length implementation, so I'm just going to bring it down in here. Okay, so length's also going to work fine, the getter at least. Okay, now we're going to implement the setter for this length as well. So this is the getter, but we have to implement the setter. So let's say override, and then we say set length. Okay, let's go in here. Now, if you give us a length, let's say the new length. So we say if new length is less than the current length, like this. Okay, then we literally change the list length to the given length, new length. So that's not the problem. However, if the new length is bigger, so actually let's say less than or equal to something like this. Otherwise, we're going to say our list is, we're going to basically fill this new list with our default values. Okay, so this is actually an operation maybe you're not familiar with, but if you have a, let's say final values is foo and bar, then if you go and say values length is 3, then this list is going to be expanded. Let me comment this out and let's have a look at what happens in here. Then let's actually comment this entire thing out, because we are not really done with it yet, and comment it out so you can at least see what we're trying to do in here. So let's run our application like this, example 10, save it, boom, save it. And you can see then we're getting a crash in here again, which is something that we're trying to fix. Let me run it again so we can see what the exact crash is, boom. And the crash is type null is not a subtype of type string. So what's happening in here is that we're trying to extend this list to a length of 3, whereas its current length is 2. And what Dart by default does in its default implementation of list is that it tries to say, okay, you want to extend this to another element, but I don't know what this element should be. Then I'm just going to put null in here, but null is not a subtype of a list of string, because this is a list of string, not a list of optional string. So it's going to crash. Okay, so to fix that, you could say, okay, well, this is a list of optional strings, and then you can change its length, and then you won't get a crash. So let's run it, and you can see now you won't get a crash. Okay, but what if you don't want to change the type of this to a list of optional strings? You actually want to have a list of string, but you want to change its length. And that's why we have our custom safe list implementation, in which case, if you change the length to a length more than the current length of the list, then we're going to populate all the new values with the default value. Okay, so that's one of the other crashes that we're going to fix with our safe list. Okay, let's remove this from here. like that. And let's go to the implementation here. And what we have to do in this implementation is to say, okay, now we're going to have to add an entire iterable to our list, and it's going to be using list filled. Okay, so we're going to fill a whole new list of new value. Okay, and then we're going to say the new value is the new length, and we're going to minus the list's length. Okay, new value actually is called new length. So we take the new length, let's say 10, and we had 5 elements from before. So 10 minus 5 is going to be 5. So we're going to create a new list with a length of 5, and we're going to fill that with our default value. Now we're going to put this entire list in, and we're going to add it to our current list. So you can see how this is going to work, right? So 5 missing elements are going to be added to the end of our current list. Okay. Now, apart from these, we're also going to fix 2 other bugs in the default list implementation in Dart, and that's the first and the last getters. Okay, so let's go and override, and we say we return t, and we say get and the first element, and we say if the list is not empty, then return the list's first element. Otherwise, return the absence value. And we do the same thing with the last element, so the last getter. Okay. And in here we say return the list's last item or the absent value. And that's pretty much it. Now we have a safe list. Okay, so let's see how this works and how this is different from a normal list. Okay, so we go ahead and we first create 2 variables, and we say const not found and is equal to the value of not found for now. Okay, just something for us. And then we say the default value or the default string is, let's say, an empty string. Okay. Then we create a safe list. So we say final my list is a safe list, and we don't have to say it's a string. In the case of an absent value, we say not found. And in case of a default value, we say the default string, and the values by default, let's just say foo, bar and baz. Okay, just like that. Now, if we go and say print my list like this, the 0th element in here, it's going to give us bar, right? So if we save this file, it's going to give us bar. Good. Now let's say that we want to get the second element at index 1. It's going to give us baz. However, if we go and say give us the third element at the index of 2, if this was a normal list, this would crash. Or actually, would it give us null? I think it would give us null, or would it crash? I think it would give us crash. It will crash basically. But in our example, you can see it's giving us the value of not found, simply because in our implementation of that subscript in here, we said if the index is less than the length, then grab that value. Otherwise, give us the absent value. And the absent value we define in here as, which one is it? Is the not found, which is pretty much being printed in here. So you can see how our list is fixing already some of the problems with the default Dart list. Okay, now let's change the length of this list. So we say my list.length is 4. Our list's length at this point was 2, but we said now it's 4. And if you then print my list at the index of 3, you will see it's an empty string. It is right here. Okay, and that's because changing the length to something more than what it was before, it will populate our list with a new list up to that length, which is populated with the default value. And our default value was an empty string in here. Okay, and that's why empty string is being printed in here. Good. And to be honest with you, we could go ahead in here and say default value and print that and see what happens. You can see default values being printed in here, and you can actually change, and you can print this entire list as well and see how it looks like at this point. You can see it is bar baz default value, because we changed the length to 4 and it was 2 before. So the new 2 values are being inserted in here as the default value. Okay, really good. And also we can go ahead and say, okay, my list length is 0. So if you print the my list now, it will be an empty array. Okay, empty list. And if we were using a normal list from Dart collection, if we said print my list first, then you would get a crash in here. But with our implementation, we get not found. Okay, and also do the same thing with last, and you will see not found being printed to the console. So this was just a little bit more advanced example of how you can create your own list to fix some of Dart's own problems with its list class. Okay, let's close example 10 and we create example 11 Dart in here. And then we say main. There we go. And then we close that. So let's start talking about example 11. And of course, let's just FS watch it as well before we close the terminal. Okay, boom, just like that. Now, we've talked about iterators, but and we actually looked at how to create iterators, but there's another simple way of creating iterators inside your own functions, and that is using synchronous generators. Okay, and the way they look like is that if you said I have a function that returns an iterable of string, and we say get names, and it's a synchronous generator. You see, you add this to your function declaration, and then in this function you can use a keyword called yield, like this. And yield will then literally add this given value into this return iterable. So let's just say yield Bob, and then we say print producing Bob, okay, like this. And then we're gonna produce the value of Alice, perhaps. So we say print producing Alice, and then we yield Alice, and then we produce perhaps, let's say Joe, and then we yield Joe, all right? And then in here, you can also have another synchronous generator. Let's create another synchronous generator in here like this. I just pasted it because it's very similar to what we have above. It's a synchronous generator, and it has to return an iterable if it is having this synchronous generator keyword in here. Then it can use yield. So this function literally is returning an iterable that contains the values of foo, bar, baz. Now, if in this function, in this get names, you also want to return all the values that are being returned from this function, you can literally yield its return value. So let's say print producing template names, like this. And then we say yield, but with a star of template names. Okay, so this is like injecting the return of this function into the return of this function. All right, then we can go ahead and say for final name in get names, like this, as a function call, and then we can print all these names. All right, and let's have a look at the results. You can see, let's run it from beginning. So with a clean slate, producing Bob, producing Alice, producing Joe, and it says producing template names, and then it says Bob, Alice, and Joe from the template names. And you can remove all these print statements just so you don't get bothered by them if that's what you want. Let's go here, here, and here. So now you're only going to see the results printed to the console. There we go. Okay, we can bring the print statements back. So this was just short and sweet about synchronous generators. Let's move on to the next example. We say example 12.dart, like this. Okay. Now, we're going to focus a little bit now on spread operators and how they work with collections, because spread operators are very, very useful when it comes to collections. We've talked about them a little bit before, but I just want to show you some more examples. All right, so let's go ahead and create example 12, and we say main, and let's close this up, and we say example 12. Let's add a function in here, and we say void add to array in the wrong way. Okay, and then we're going to do this the right way. Let's say we have two arrays in here, or two lists like this, and then we say final all names wrong is names one. Okay, so all names wrong, it takes the value of names one, and then we want to collect all the names, basically, because we have two lists in here. We want to collect both of them inside one variable. So we could say all names wrong dot add all, and then we say names two. So you'd probably expect now all names wrong to include all the values from names one and names two. Okay, so what is unfortunately going to happen is, as you'll soon see, if we print names one and then names two, and then print all names wrong to the console, and then call this function from our main function, you'll unfortunately see a little side effect that you probably didn't expect, in that by printing names one, you were probably expecting foo1, bar1, and baz1 to be printed. However, it is foo1, bar1, baz1, but foo2, bar2, and baz2 as well. What happened in here? Well, by assigning names one to another variable and changing this variable, you're not only affecting this variable, but also names one as well, because this assignment is not copying the contents of names1 to this variable. It is indeed assigning the exact contents of like exact variables and its memory position to this variable. So these two variables are now pointing to the same memory. Okay, so if you modify this, you're pretty much modifying this one as well, because they're pointing to the same memory space. Okay, so this is the wrong way of doing this. But what is the right way? So let's go ahead and create a function in here. We call it add to array right. Okay, copy that, and we say add to array right. Let's call that from here as well, so we can see the result printed to the console. Now, if you want to create this variable and say all names right, okay, what you could do is to use a spread operator. So we say it's equal to names1 and names2. So you're literally taking the contents of names1 and placing it in here, and then names2 and placing it in here. And you can see now this is a list of string. Oh, actually it's a set of string. So we could do it like this, perhaps like this and this. Okay, boom, like this. So now it's actually a list of string, and we could print it to the console. There we go. Okay, so if you now look at the results, perhaps we could have a little separator between these. So we say print like this, a little separator. Okay, so now you can see all names right is printing the contents of names1 and names2. They're untouched. However, all names right contains the entire contents of names1 and names2. And there's another way of doing this. You could also say final. Another way is you could take the entire contents of names1, okay, put it inside its own list, and then you say dot dot add all, and then you could say names2 as well. So this is also going to work, okay, and you can print this as well, and you can see that printed to the console. So let's see what's happening in collection. When possible, use spread collections. Oh, we're getting a little warning in here telling us, well, we shouldn't really be doing this. So instead we should have done this pretty much, which is something I agree with. So, however, you could create sets out of these as well. So you could say this is a set like this, and then you could say then add all, and then another way, then you could see this is a set of string, and the results are going to look like this. Okay, so there are different ways of doing this. It's just you need to see which way fits your needs best. Okay, you can also do the same thing with dictionaries. So I'm going to create a little function in here. I'm going to actually paste that function because it's very similar to what we've done so far. Instead of me typing it again, I'm just going to start it off at least with some seed values. There we go. Boom, boom. Okay. Now, if we try to add a value to a const map, you know that it's going to crash, because that's how constants work in Dart. So if we say final result is info, okay, and then in here we say result add all, so we add another map to this map, and we say the weight is 80, and if we run this code, let's put it up on the main with a separator, and we say add to dictionary wrong. Okay, now if you run this code, we'll get an exception in here, and you can see the exception says unsupported operation cannot modify unmodifiable maps, simply because a const map is unmodifiable. Okay, so let's put this in a try and catch so that it doesn't crash our application fully. So we know already that this is the wrong way of doing it. Okay, so it just printed to the console. So how do we fix this? How do we do it the right way? So let's remove this and then copy this code, and we will place it down here, and we'll say add to dictionary right. Okay, and the correct way of doing this is using a spread operator. So let's remove this try statement from here, and we say final result is, we create a dictionary and we spread the information in that new dictionary, and then we can say add all. Okay, and in here we say weight is 80, just like that, and we can then print the result. So let's go ahead and call this function from here. Then we say it is the right way of doing it. Okay, so if you see the results now, you can see it says name, age, and then height and weight are all present in the resulting dictionary, or map, simply because we used the spread operator to spread this info map inside a completely new instance of map. All right. Now let's have a look at some Python style set, list, and map comprehensions. All right. These are very exciting, and we have to create their own file for them. So let's go ahead and say example 13 .dart, and then we create a main function in here. Okay, and then we go fswatch example 13 as well. So let's go in here and talk about what set comprehensions are. Okay, so let's say that you have a string. We say abracadabra. Okay, now if someone gives you a task and says extract all the characters from this string that are not equal to A, B, or C. So how would you do that? You could say, well, okay, final string is this one. Then I will say var result is an empty string. I say for final char in string, and then you split it by an empty string. Okay, like this. And then we'll go ahead and we say if char is equal to A, or char is equal to B, or char equal to C, then don't do anything. Otherwise, then grab it in the result, and then we say print the result. So let's have a look at the result. You can see then it's RDR in here, okay? Because abracadabra is like everything is A, B, or C except for RDR pretty much. So this is a very simple implementation of this. However, you could also say, well, that's a string. Okay, I know about that. Let's change this implementation to create a set first. Then in this set creation, you say for final char in string split. You pretty much do the same code, okay? And in here, then you see, okay, what is the condition? Then you say A, B, or C strings. If it contains this character, then produce null. Otherwise, produce a character. So what is the result of this guy then? Is a set of optional strings, okay? Because null is a valid string in here. So what we want to do is to get rid of that null value. Then we say remove all null values from here, okay? Like this. And then we cast the entire thing. We say cast the entire result to an array of string. Oh, sorry, a set of strings. So now all of a sudden this result is going to be, actually it should have been a, wait a minute, what happened to it? It should have been a set of string. Maybe we should actually tell it that it is a set of strings. So let's say set of string like this is equal to that. ABC contains null, but we have casted, but it still didn't understand. So what happens if we just leave it like this? And then we print it to the console result like this. It is saying indeed it's RND. So it did get rid of the nulls, but it still thinks that it is a set of optional string. So maybe that could be a good homework for us to fix. Okay. So this is how you are creating basically a set, and in there you're using a comprehension in here to produce new values. All right. So that was just one example. Let's just call this variable, actually, we say all except ABC, something like this. All right. And we can just leave it there. Then you also have list comprehension. So this was a set comprehension, but you can also have a list comprehension. So let's have a look at that. We print a little separator like this, and we say we generate 100 numbers. So let's say all numbers, and it's equal to an iterable, and then we say generate 100 numbers like this. Now, what if you want to extract all even numbers from this iterable? Then we can say final even numbers is equal to, then we create an array in here. You can see in here, okay, a list. And in here, then you create a loop. You say for final number in all numbers like this. And then the condition for it is if the number is divisible by 2 with a 0 remainder, then produce the number in here. Okay. And I kind of wonder if you could have done the same thing in here. If you could have said, okay, if ABC, if it's not contained, like in here, and then produce a char. We could have perhaps done the same thing in here. I wonder, expected, what does it say? Expected to find, and could we not do that? maybe that won't work. No, unfortunately, that probably won't work. So I was wondering if we could do something similar to what we're doing in here, but that's not possible, unfortunately. So what we're doing in here, we're going through all these numbers, and if they're divisible by 2, then we're producing that number. Otherwise, we're not producing any numbers. Okay, so then the result of this guy, you can see, is a list of dynamic, but it is indeed actually numbers, really. It's literally integers. So if you wanted to do the same thing using a functional way of producing these numbers, you could say final even numbers functional. Then you could say all numbers, and then you could say where, and in here the element you could say number. Let's bring it down to the next line. Then you could say number should be divisible by 2. Okay, so the result of both of these is the exact same thing. Okay, and you could also produce odd numbers. So if we copy this, we bring it here, we say odd numbers, and in here we say it shouldn't be divisible by 2, so it shouldn't be equal to 0. And you could also produce the odd numbers functionally, exact way you produce the functional even numbers. So we then say odd numbers functional, and then in here we say they shouldn't be divisible by 2, like this. All right, so all of these, you can see they're producing iterables of dynamic, but they're pretty much iterables of integer. So we can print them all to the console. So let me just put all the print statements in here. So printing all the numbers will give us 1 to 100. Which one is it? It is somewhere in here. All the numbers, it's here, you can see 0 to 100 exclusive. Then we're saying even numbers, and you can see it's only producing the even numbers in here. Then we're saying even numbers functional, which is, wait a minute, 2, 0, yeah, it's even numbers functional is right here. Then we're saying odd numbers, and then odd numbers functional. And you probably have already seen a little bit of a difference between these, like even numbers, which we produced here, and which is right here, with our list comprehension, is printing all the values to the console. But when we produce the even numbers functionally, it's producing only 0 to blah 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 up to 34, and then not the values in between, and then the values at the end. And this is just simply how print is working, but there is a fundamental difference between these productions of values. Even numbers using list comprehensions is producing a list. However, when you do a functional way, it's producing an iterable. Iterables, when they're printed to the console, they're not all evaluated. They're only lazily evaluated. Just the first few and the last few are printed. Okay, just keep that in mind. So when you're using list comprehensions, you're basically producing lists, but when you're doing it functionally, then you're producing iterables. Okay, now we can also do map comprehensions. So we're going to go and have a look at how map comprehensions work. So I'm going to have a little list of names in here, you can see. Okay, and then if you want to go ahead and create a map out of this, where the keys are the strings and the values of the map are the length of these strings, then you can say final names and lengths is equal to a map. Then we go through for final name in names, and then we produce a key and a value. Okay, and then you can print this to the console. Let's go in here and we say print names and lengths, and then you can see this statement being printed to the console as a map. So you can easily turn a list or iterable into a map using map comprehensions. Okay, so that was that for a kind of Python style set, list, and map comprehensions. Now let's have a look at the last example in this chapter. Okay, and it is in this last example, we're going to go through the collection package and have a look at some of its main functionalities and use cases. All right, so I'm going to close this file and then say example 14 Dart, a main function in here, and then we're going to run example 14, as you can see in here. Okay, we have our file ready now. I'm just going to press Command S in here to get FSWatch to do its work. Now, as I mentioned before, we're going to go ahead and have a look at some of the most important functionalities inside the collection package. So let's import that. So let's say import in here, and we say package collection, and import that in here. And the first thing that we're going to have a look at is called a bool list. Now, if you're working with lists, like a global list or a big list of Boolean values inside your application, then bool list is the right candidate. And if you have a look at a Boolean value and how it is stored, then you can imagine that it is stored in the current architecture's native length. So if you have, for instance, a Boolean value, it could perhaps be 32 bits, or if a compiler is trying to do some optimization, it may use a whole integer to represent, for instance, 4 Booleans, with every Boolean being 8 bits in width, or 1 byte. So if you have 4 bytes, 4 Booleans, you can press it down inside one integer of 32 bits long, or if your native architecture is 64 bits, then you can divide that into 8 bits. You'll get 8 Booleans being represented inside one native architecture's integer width. Now, this is a lot of just talk by saying, for instance, let me actually show you in here. Let's say that we have a Boolean, and a Boolean is just 0 or 1. And in assembly, you could, so let's say that this is a byte, which is 8 bits long. So this is a Boolean whose value is true. And this is a Boolean whose value is, sorry, this is actually false. This is a Boolean whose value is false, and this is a Boolean value whose value is true. So you can see in here, we're only flipping 1 bit in here. So theoretically, if you wanted to represent 8 Booleans with just 1 byte, you could do that. So this would be your first Boolean, this would be your second Boolean, 0 or 1, right? And so on and so forth. So 1 byte could represent 8 Booleans. And this is exactly what a bool list does inside the collection package. Instead of going ahead and saying, for instance, that you have a Boolean who takes 8 bits, or even worse, 32 bits or 64 bits in the native architecture's integer width, then it goes ahead and optimizes your Booleans so that internally it uses integers and flips the bits for every Boolean that you represent in there. So let's go ahead and create one. And we say void, we create a function test bool list. All right, and in here, then we go ahead and say test bool list, just call the function for us. And then we go ahead in here and we say, let's just create the list. So we say final bool list is equal to a bool list. As you can see, it's a class, okay? And the first parameter that you pass to it is its length. Let's just say 10. All right, and then we say it is growable as well, so we are allowed to modify it like that. And then we say print bool list. Let's just do that and have a look at our terminal, and you can see by default it has 10 values in there whose values are basically false, so 10 Boolean values by default, and it's a growable list as well. Okay, then we can go ahead and say, okay, bool list subscripted, the 4th value is true. All right. And then we can say if bool list, the 4th value, so at the 3rd index. So bool list, if the 4th value is true, then we say print the Boolean value at index 3 is true. Otherwise, we say it is false, okay? And you can also print, again, your bool list. So we say bool list. And let's just see how it looks like. So now the 4th value should be true. So this is the first print, okay? You can see all the values are false. Then we say, okay, yeah, the Boolean value at index 3 is true. And then here's the Boolean value at index 3, okay? 3. So then let's say bool list.length and double it like this. And then we can print it again, bool list like this. There we go. So now we have the last print is right here. So false, 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 true. And then 10 items up to here. And then we get 10 more. All right, so just imagine a bool list is like a normal list kind of, but internally it is optimizing its storage so that it doesn't have to consume a whole integer for one Boolean value. All right, so the goal of this is if you're working with lots of Booleans in like an array or list, try to avoid doing just a simple list and instead use a bool list. And if and I mean, when I say a lot, it doesn't mean like just 10 or 20. If you're using with like thousands of booleans and you want to actually consume less memory, then it is best to use a bool list for that purpose. But otherwise, a bool list works really similar just to a list. It's basically a ListBase, I think, is actually using. Let's have a look. Is it using a ListBase? It's a list mixin, which it implements list. So it's kind of like how we created our safe list, but basically they're doing something like that. Okay. So just keep that in mind. All right, that's good. Let's just print a little, we could perhaps in here, after test bool list, we could say print a little separator. Okay, so that we can go to the next example. Now we're going to look at something called a canonicalized map. And a canonicalized map, it's quite a difficult word for me. It is a map okay, let's actually go back to the definition of a map. A definition of a map is a collection that has keys and values. And these keys are considered to be the same if their hash value or the hash code and their equality indicate that they're the same. We've already looked at this before, okay? So what if you want, as a programmer, to decide whether two keys are the same? Okay, so that is where the canonicalized map comes in. You as a programmer can make a decision. Given a key, you can basically create a value, kind of like a hash code, that decides then whether two keys can coexist in the same map or not. Okay, so let's go ahead and create a function for that. So we say test canonicalized map. All right, and let's go and call it in here, and then a little separator. All right, boom, like that. And then we can just focus on this canonicalized map in here. So let's create a little dictionary. Okay, I'm gonna place it here. I've already created this from before. You can see we have name, age, sex, and address. Okay, now one thing that we could do to test things out is we could say this dictionary or this map allows keys that have different lengths. So as long as a key has the same length as another key, that key is not going to be accepted in this dictionary. Okay, so you can see age and sex are both 3 characters in length. So what we could do is just to test things out, how canonicalized maps work. We could say we go ahead and calculate our hash value kind of by looking at the length of keys, and the keys have to have different lengths. Otherwise, they're not allowed to be put inside this map. So the way to do that is we create, and we say canon map. Let's just call it canon map, is a little bit more funny. And we say canonicalized map. All right. And then we say from, because we already have a map from before. And the first parameter that we pass in here is going to be our map. And then you can see we need another positional argument in here. And the second argument is actually going to give you the key. And in here, then you make a decision of like converting this key. Let's have a look at this parameter. Have a look at it. You just return any value in here. Okay. So what we're going to return in here, we say we return the key's length. Okay. So then this integer is going to be used to determine the kind of like the hash value or the hash code of every key. Okay. So now that we return that, we can go ahead and print this, print canon map like this. All right. And you can then see in the results that we have name, sex, and address. So our age here was overwritten by the sex. And we could actually put something else in here. Let's say blah is blah and see how that works. So as soon as putting blah and blah in there, you can see now blah and blah overwrote sex, and sex had overwritten age already. So this is where we are basically creating that kind of like uniqueness of our keys. It is not dependent on hash code and is not dependent on equality anymore. Okay, so what we could do in here, we could say, okay, the uniqueness is determined by the key, and key is a string, and we say character. Actually, how do we get the character? So we could get the runes, or we could say split it by empty string, and then we get the first character in here. Okay, we return it like this. So let's have a look at how this basically affects our application. So we run the app now, and now you can see we have name, address, and sex. So name address and sex, but what happened to age? Well, address overwrote age simply because what we're doing here, the canonical value of every key is determined by its first character. And the first character of this key is A, and the first character of the age key was also A. Therefore, address is going to overwrite age. So you see how this could be useful. So you could literally build maps or dictionaries whose uniqueness of keys is determined by you, not by the hash value and not by, for instance, your equality. Okay, so it could be very useful in some cases. So that's for that example. All right, so let's go ahead and create a function now that in which we can talk about combined iterables. So this is quite an interesting functionality. You may not think that even it exists in the collection package, but it does, and it is very useful in some particular cases. So, and it's called a combined iterable. All right, so let's create a void function for that. And in here we say test combined iterable view like this, and we can go ahead and call it in here in our main function. Then we go in test combined iterable view and start writing our code. So let's create some iterables in here. I've already prepared 3 from before, like here. We have 1, 2, 3, and in 1 we have the values of 1, 2, 3. In 2 we have 10, 20, 30, and then in 3 we have 40, 50, 60. Okay, it's just it doesn't really matter what you place in here. It's just we're just doing some tests. Okay, so you don't have to necessarily do this. You could just create an iterable or a list of strings if you want to. It doesn't really matter. Okay, so let's go ahead and create now a combined iterable view. So we say var combined, and it is a combined iterable view, and this is coming from the collection package as well. All right, and in here we pass 1, 2, and 3. All right, just like that. And let's have a look at this. Okay, now a combined iterable view is an iterable of iterables, and if the underlying iterables change, the combined iterable view will reflect those changes. So let's print this guy right now. We say combined, okay, and have a look at the results. Right here, you can see it says it's 1, 2, 3, 10, 20, 30, and 40, 50, 60. So it doesn't like say that it is, because you may think that, oh, but we placed these iterables within another iterable. So why are they not in an external iterable? And that's just the way to pass these parameters to the combined iterable. It expects you can see it expects, wait a minute, where did it go? It expects iterables of iterables. Okay, that's just how it is constructed and how it internally manages these iterables. Okay, so up to this point, fine. It's just like pretty much flattening these iterables into one iterable. So what's so special about that? The special thing is that you can go in here and take one of your iterables, which has already been passed to this class, and it could say 2, and you add a value of 40 to it. Okay, you can see in here 2 has 10, 20, and 30. It doesn't have the value of 40, but now you're adding the value of 40 to it. Okay, and then you can go and print your combined value after modifying the 2 list, and then have a look at the results. Then you get 1, 2, 3, 10, 20, 30, 40. So this 40 was actually reflected within the combined iterable as well. So you are changing the iterables that you've already passed to this, but this guy's understanding that. So it's like, oh, okay, now all of a sudden I have a new value. Okay, and you can print the length. So this is just like you would work with any other iterable. You can ask it if it's empty or not. So this is something that you already have from before as well. And of course, you can also ask it to say contains the value of 50, for instance, okay, or 5, and contains the value of 10. So it's pretty much working as an iterable. Okay, so you can see it says I don't have the value of 5, but I have the value of 10, and I'm not empty. That's where the false comes in, and then it has 10 elements in it because 9 of those elements were passed in here, and another element was passed to the underlying iterable in here, or the underlying list in here, making the length total of 10. So combined iterable view, its power is that it can manage multiple iterables, and you can change those underlying iterables, and the combined iterable view will understand those changes. That's its power, okay? And otherwise, you can use it just like normal iterables as well. But please don't use it as just one iterable that contains one iterable. Okay, because for that you have iterable. All right, the goal of this is to combine multiple iterables. Okay, now we have that. So as you have a combined iterable view, you also have a combined list view. So if we went in here, you can see this guy expects iterables, but we're actually passing it lists. So what we could do, we could say this is an iterable of int here, and let's go in here and make these guys iterables of ints as well. All right, so this is for the case of having iterables, but you also have the case of having lists. Okay, so let's go ahead and test that. So let's create a void function in here, test combined list view. All right, now a combined list view is a view of a list of lists, and it is unmodifiable. All right, so we could actually write it in here. Combined list view is a view of a list of lists and is unmodifiable, just so we know the difference, okay, between this one and the other one. Let's invoke this function so we can test it out like this, and then we put our separator in here as well. Good. So let's go ahead and create 3 lists, just like we did with the iterable example. I'm gonna bring these lists in here. And you can see we have Swedish names, Norwegian names, and French names placed in here, just some examples. And then we're going to create a combined list view. So let's say final names is a combined list view. This is coming from the collection package as well. You have to pass your lists within another list. And we say Swedish names, Norwegian names, and French names. Okay. Now we can go ahead in here and pretty much use this just like a normal list. And if you printed, let's say print names, you can see that they're flattened. Wait a minute. What did we do? Oh, okay. All right. So in here, we don't have add because they're going inside an iterable. So just to demonstrate this, we could go ahead and change this back to a list. But remember, this lists are iterables as well. Okay. So let's change this guy to a normal list so we can do an add on it. And if we go back to our application, it should work now. Okay, now we go back to our example in here, and you can see we have a combined list view, and it is flattening the names for us. Sven, Carl, did we? Swedish, Norwegian. All right, so yeah, the names are pretty much the same because Swedish and Norwegian, of course. So, so now that we have that, we can go ahead and pretty much work with these names like you would with any list. Okay, so you could go ahead and say if names contains the value of Sven, like this, and we can say Sven is in the list. Okay, however, since this is a normal list now, but it is not modifiable, so it's unmodifiable, you cannot add stuff to it. All right, so you can't go ahead and say names.remove at or add. Okay, so these things are gonna crash your application. So we say try, and we can say catch E, and we print the exception in here. And then inside try, we'll just say names, remove at, we'll try to remove the first element. And you can see now we'll get an exception printed to the console saying unsupported operation. Okay, so basically think of this as like a combination of multiple lists that are flattened, but they're unmodifiable. All right, so, but you can go ahead and perhaps say, okay, I'm gonna go to Swedish names in here. Right before this, let's say Swedish names, remove, let's say remove at, let's remove the first element, which is Sven. All right, and let's see what happens in here. Let me bring up the console. There we go. And we have then Carl Gustav. You see, this one was removed. So the combined list view is exactly like the other ones, other lists that we had a look at. It understands the changes to its underlying lists, but you can't modify it itself. So you can't modify this guy by calling remove on it, but you can remove elements from the underlying lists if you want to, or add to them. Okay. So that's for that. And we can now go ahead and have a look at a similar example, test combined list view, but this time look at it from a map views perspective. So let's create a void function and say test combined map view like this. And we invoke it in here, and we just have our print statement right there. Okay, and as you can guess, a combined map view works pretty much the same as a combined list view. All right, so it's you can't modify it from the outside world, I think, and we can test that, but you can modify its internal maps. So I have some maps in here. We can place it. You can see it has the simple keys of A, B, C, and then it has B, C, D, and this guy has a C, D, E. And let's create a combined map view out of these guys. So we say var combined map like this, and it is a combined map view. And then we pass them inside an iterable. So we say map 1, 2, 3, like that. Okay. And then we can print this guy. So we say print combined map view. So, combined map like this. Okay. And let's have a look at the results. You can then see your keys are here, A, B, C, D, and E. So because the key of C is already present in here and it had the value of 3, so you can't place this key, which is exactly the same key, but with the value of 5. So your new keys in consecutive maps will not overwrite the previous keys with the same value. Sorry, the previous keys with the same key value, basically, not the value itself. Okay, or we could just say with the same key. That would perhaps be easier to understand as well. Okay, so now you can go ahead and grab values out of this combined map if you want to. So I'll just print some statements in here like this. Okay, so we say combined map, give me the value of the key A, B, C, D, E, F, and we can have a look at the results. All right, there we go. You can see it says A, B, C, D, E, but we don't have the key of F, so it gives you null, just exactly as you would expect it from a normal map as well. Okay. However, this, as I mentioned before, this combined map view is unmodifiable, so you cannot change it itself. You can change the underlying maps, but you can't change the combined map itself. So let's say try, and we say combined map, the value of key A is equal to 10. All right, and then we will catch an exception and just print the exception to the console. And you can see an exception gets printed now to the console saying unsupported operation. All right, but you can go ahead and change this map. Let's say we change map 1 and we say the key of foo is equal to bar. All right, actually it's integers, so let's say is equal to 20. So we print that and we have a look at the results in here, and you can see foo is present inside our combined map view. Okay, so that's for our combined map view. Now, before we close off this example as well and this chapter, let's have a look at our last example, which is merging maps. Okay, and with merging maps, it is actually a little bit special because if you have duplicate keys, then you as a programmer need to make a decision how to handle that case. I'll show you now. Let's create a void function in here. We say void, and let's say test map merging like this, and then we can go ahead and call it from here, test map merging and a separator. Thanks GitHub Copilot. So I've created 2 maps, which I'll just dump here so we don't have to type those by hand like this. Okay. And you can see in here, the first map has name, age, and height. And here we also have name, age, height, but also an additional key in here that says weight, and it's 80 kilos, hopefully. Okay. Now, if we want to merge these keys, we can use a function called merge maps. And let's say final merge, and we say merge maps in here. Okay. And in here we say, okay, info 1 and 2. And if you have a look at the results, let's say print merge, have a look at what it outputs by default. You can see it took name John, age 31. So it literally took, like we could in here say John 1 and John 2 and see what the result is. You can see in here explicitly that it has taken so in case of duplicate keys, it's taking the values from the second map. So info 1 had the key of name, and info 2 also has the key of name. However, when it came to these duplicate keys, it says, okay, which value should I take? And it by default is taking the second or the last map's keys and values. However, you could overwrite this logic by providing a third parameter in here, which is called value, I think, and it takes a closure in here and it says, okay, given this p0, which is like your parameter 0, so like 1, let's call it 2 in here. And if you look at this 1 in here, it is pretty much your first parameter. Okay, so in here you could say, okay, take the first object. So in case of 2 dictionaries, take the values from the first dictionary. Okay, and let's put a comma, and then you can have a look at the results. Now it's completely changed. So it's John 1. So it's taking the results from the first map in this case. So you can then change this to 2 if you want to, and then you can see it's the second map that is leading basically in which key and value should be used. Okay, so that's also for merge maps, which you can use in order to merge your maps and then decide how to react in case of duplicate keys. Okay, and that was it really for this example and this chapter. I would say we've had a look at a lot of examples for collections, and to be honest with you, there's lots more, but I don't want to risk having this chapter going into 5 or 6 hours long in length. So let's just leave it here, and I hope to see you in the next chapter.